Hello sir, I am Kaveri Muratan from Department of Electrical Engineering. My teammates are Kai Gayatri, Kolhi Puja and Nikam Sairar. We are going to present our CI activity, simulation of design of PID controller of DC to DC buck converter. This project has guided by our sir, Dr. Vijay Kumar sir. The main objective of our project is to design a simulation of PID controller that regulates the output voltage of DC to DC converter using a MATLAB simile. Through the simulation, we have aimed to demonstrate how the feedback-based controller system maintain a constant and stable output voltage even when the inner voltage or load varies. Before going to simulation, let's understand the basic working principle of DC to DC converter. It is electronic circuit that convert one level of DC voltage into another level, either a step down or a step up. Here we have used buck converter, which step down a higher DC input voltage to lower DC output voltage. A digital controller continuously measures the output voltage, compares to with a reference value and adjusts the switching of the convert to keep the output voltage constant. Next, my friend Kolhi Puja will explain the simulation of our MATLAB.
I am Kolhi Puja and I am explain this simulation diagram. First part of the diagram, I have the DC voltage source. And this DC voltage source, the block provide constant input voltage is a 12 volt input. 12 volt input is take, and DC source is connected to the MOSFET switch, and this act is a main controller element in convert. The next move to the power circuit section and section simulation. The section include MOSFET switch, diode, inductor, capacitor and load resistance. The MOSFET is represented by the MOSFET represent a value of a PT resistance 0.1 and internal diode resistance is 0.0 ohm and snubber circuit is 1 into e raised to 5. And then diode is a provide freewheeling path of the inductor current, and then switch is up. It prevents the inverse power of the current back into the source. Set the rating is resistance is 0.00 ohm and forward voltage is 0.0 and snubber resistance 15.
I am Gayatri Valmikare and I am explain control section of our simulation diagram. This part of section is control section. This part of the brain of buck converter system, because it's decide how much the switch should be on or off to maintain constant output voltage. The control section begin with comparator block. These blocks compare the reference voltage with the actual output voltage measure from the converter, where the reference voltage is set 12 volt, which is our output level. This is the comparator generator, PW generator. Switching frequency is 400 e raised to 3 and it is a PID controller. PID controller range is proportional is 0.0004848, integral is 1 and filter coefficient is 100. The error signal is sent to PID controller block. The PID controller stands for proportional integral derivative controller. It processes the error signal in three ways: proportional, integral, and derivative to make the system stable and responsible. The proportional term denotes Kp. This is the control system, our simulation. Next comes to PWM generator block, pulse width modulation generator. This block converts the analog signal from the PID controller into the digital switching signal that derive the MOSFET gate. When the PID output increases, the PWM duty cycle become wide, meaning the MOSFET stay on for the longer time in each switching period. As the result, the output voltage increases. Similarly, when the PID output decreases, the duty cycle becomes smaller. The MOSFET stay on for the shorter time and the output voltage decreases. In the way, the PWM signal continuously adjusts to keep the output voltage close to the reference value. So next waveform and output is explained Sairaj.
Hello, I am Sairaj Nikam. This is our topic. I am explaining the output and the waveform of the simulation and the result and discussion. This is our simulation and this is our waveform of our simulation after run. This is the buck converters which step down the voltage from 12 volt to 5 volt. We can see in this waveform. This is vary and this is simulation after run. We have given the stop time of the 2 minutes. After 2 minutes we get the output waveform. Then now the use of this and result is the digital controller of the DC to DC converter was implemented using a MATLAB function block and simulation. Simulation output confirm stable output voltage regulation under varying input and load, reduces voltage ripple and overload, faster transiting response compared to the open loop operation, real-time simulation achieved with minimum computation delay. Discussion. The use of the MATLAB function block enable flexible code of control easier debugging. The controller maintains high performance under dynamic conditions, robustness. The closed loop response shows improved stability and efficiency, which the